Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, here we go into our next lesson, lesson 9.2.1, side lengths of triangles. This is a 2-day lesson. The first day, typically we're going to spend cutting out squares and manipulating them to form triangles, and then recording the data and seeing if we can draw any conclusions about the side lengths of triangles and the types of triangles that they create with those given side lengths. I have posted 3 different resource pages onto the Google Classroom, which you may have seen already. If you haven't, I would recommend you go look at those. If you have the means to print those off, it's going to make this lesson a lot better for you, a lot more understandable, more meaningful. If you can't, if you don't have a printer, you could just watch what I do. But it is a good lesson. It's a good hands-on lesson. So if you have the means, please print out those pages and go through the lesson with me. You'll also need scissors too to cut out. So let's get moving. Triangles are made of 3 sides, but can any 3 side lengths make up a triangle? Is it possible to predict what kind of a triangle you would get with the given side lengths? That would be like the obtuse triangles, the acute triangles, or right triangles. Can you predict that just by looking at their side lengths without actually seeing the triangle itself? Today, we're going to investigate these questions. So I think I'm just I'll let you read this if you want to read that, and you can pause it to read it, and then come back to us, but I'm going to move on. Okay, so this is resource page A. It has a number of different squares, and the squares have side lengths that are shown here. Like, for instance, this square, if you were to count the number of units, will be 13 by 13. When you square the number 13, you're essentially multiplying it times itself. So the 169 refers to the total number of individual squares that fill up this 13 by 13 square. This is a 12 by 12 square, so it has 144 in the middle. This is a 10 by 10, so it's got 100 squares in there, and so on and so forth. So first thing for you to do is to take this worksheet, print it off, and then use your scissors to cut out each one of these individual squares and just set them off to the side. You are also going to get a sheet that looks like this that has a right angle. We're going to use this as our tool, so you will not cut anything out from this worksheet. Just leave it intact. And then the third worksheet that you're going to get is going to look like this. It's going to be a table for you to fill in the numbers. And after we've got all these numbers filled in, then we're going to look to see if there are any patterns that'll help us with looking at individual side lengths of triangles and what type of a triangle it would create. So go ahead, pause the video, cut these squares out, and then when you come back, we're going to start manipulating them, and I'll show you how to manipulate them with resource page B. All right, so hopefully you've got some wonderful clean squares that you've cut out. What I'm going to do is I'm going to take 3 squares alone. I'm going to take maybe these 3 right here. So I'm pretending like I just cut those out. Let's cut those away, and let's paste them on here. Okay, good. So what you always want to do is take the 2 shorter or 2 smaller squares, and you want to set these so that they form a right angle with the side lengths. So I believe this one was my 5, this one was my 6, and this was my 10, correct? 5, 6, and 10. I don't have the luxury of having those numbers printed on there. You will have the numbers printed on yours. So always take the longest one, and then what I want you to do is rotate it to try and meet these corners and get them to match up perfectly. As you can see, I can match up this corner here, but this one is not matched up. And even if I try and open this up a little bit, I have to open it up a little bit more. This is where you working with your cutout papers is much easier than me working out with mine. I'm going to try and get these guys so that their corners match up. They're almost there. Bring this guy down a little bit. Bring this around a little bit. It's a little boring for you to watch, I'm sure, but I think we got the basic idea here. All right, so I think that's about it. That's pretty close. It gives me the answer that I want. So notice this shape on the inside. Here's one square that's a cutout. There's a square that's a cutout. There's a square that's a cutout. By touching three vertices together, you're creating the shape of a triangle on the inside. So the question is, what type of a triangle is this? And you see that little box right there that signifies that that would be a right triangle there? This is open wider than 90 degrees, which makes this an obtuse angle, which makes this triangle an obtuse triangle. So what we do from here is we take this data, and I'm going to write in the smallest one had a side length of 5, the medium one had a side length of 6, and the longest had a side length of 10. Now, looking at that piece of paper, the area of this smallest square was 25 square units. The area of this medium size was 36, and the area of this one was 100. So your task is to take and add up the total areas of the two smaller squares. This one was 25, this one was 36, so 25 plus 36 is equal to 61 total square units between those. And then we're going to write in the largest area, which was the 100. So let me just go ahead and highlight this. You're supposed to take these two guys right there and add them together. Actually, let me color coordinate that. OCD taking over. Take those two and add them together. Then take the larger area, which is this one right there, and write that in here. And that larger area is 100. So how does 61 compare to 100? Is 61 less than, is it equal to, or is it greater than 100? And hopefully all of you are saying, oh yes, that is definitely less than. And then what we're going to do is we're going to go back and look at that shape that's on the inside. What kind of a triangle was created in here? That was an obtuse. So we're going to write the word obtuse here. Okay? Actually, let me do that in red. Just be consistent. Obtuse. Okay. One down, and how many more to go? 1, 2, 3, 4, 5, 6, 7, 8. We're going to do this about 9 times. Okay. I'll do one more for you, and let me clear these guys out of there. Go away. Let me do it again. This time, I'm going to choose 3, 4, and 5. Let's see what kind of a triangle we get out of those 3. So remember, when you do this, put the largest one up here and take the 2 smaller ones and put them on the line, just to start off. And now you rotate this guy a little bit. Let's get it in there and see what type of a triangle we can create there. Look at that. That was easy. That was convenient. I didn't have to rotate these guys at all like I did in the previous example. So when I took a 3, a side of 3 with a side of 4 and a side of 5, and I put them all together, that formed a right triangle. So let's go ahead and record that. I'm going to change my color scheme here and say a 3, a 4, and a 5. This one was 9, this one was 16, this one was 25, and 9 plus 16 is how much? That is 25, and this one was 25. How do 25 and 25 compare to each other? They are equal, and that formed a right triangle. Okay, so keep doing that. Fill in as many as you can. And then we're going to look for patterns. Go ahead and pause the video. And when you come back, we'll move on to the next slide. And we'll see if we can notice a trend here. Okay, welcome back. Now this is actually data from a previous year, so I'm cheating a little bit. Notice that my first row was exactly the same, but my second row, I've changed it to 3, 4, and 8. Let's just go ahead and take a look at a bunch of these. What I'm going to do is I'm going to look for a pattern here. I'm going to look at all the obtuse triangles that we've got in there. It looks like we've only got 2 of them. I'm going to highlight those. This is an obtuse, and this is an obtuse. I'm going to highlight all the acutes. This is an acute. This is an acute. And is that the, oh wait, we had another obtuse there. There's an obtuse. And is that only 2 acute ones? And then let's look at all the right ones. Here's a right one, here's a right one, and here's a right one. And this lowest right one was actually the one that we had for our second line. So, do you notice anything here? What do all the obtuse triangles have in common? Are you noticing the same thing that I'm noticing? Notice here that all of them share the same characteristic where the sum of the 2 smaller areas of the squares is always less than the total area of the largest square. Let's look at all the acutes. What do they all have in common? Well, looks like every time you add the smaller area to the medium area, that ends up giving you a larger combined area than the total area of the largest. And what do all the rights have in common? Well, looky there. The area of the 2 smaller squares, when added up together, always form a right triangle when their sum is exactly the same as the area of the largest square from the largest side. Now, what's going on with this guy right there? I want to explore this. 3, the 4, and the 8. Why did that not form a triangle? What happened? Clear these guys off. What was that? A 4? Was it a 4, 5, and 8? 3? No. What was it? A 3, 4, and an 8. Okay. So let's take the 3, the 4. Stop it. The 3, the 4, and the 8 are all right there. So I'm going to take this guy. I'm going to take this guy. I'm going to take that guy. Put them all together. Let's cut them out. Let's take them over to here. Okay, the largest one always goes over here. Put the smaller one here. And the medium-sized here. So that's the 3, that's the 4, this is the 8. What is, all right, so we're going to have to open this up, aren't we? Are we able to get this guy there? What's happening there? Wow, are we going to be able to even make this work? I don't think we are. Look what's happening here. There's no way we can get a triangle out of this because the 2 sides of the two smaller sides are not even when it's completely open. They can't make it to this angle right there. So does that mean it's impossible to have a triangle where the sum of the 2 shorter sides isn't even as long as the greatest side? How would that even work? I don't think we can. So that's why we said none there. There's no way that we can make it this a triangle with these as the side lengths. The 3 and the 4 have to be at least 8 just for them to match up. But I think they have to be more than 8 in order to make a space in between there. All of these others, you notice the 5 and the 6 is greater than the 10, the 5 and the 6 is greater than the 8 plus the 9 is greater than the 12, the 8 plus the 12 is greater than the 13. In all of these situations where we've got a triangle that was formed in the middle, they all have something in common here. The sum of the two shorter sides is always greater than the third side. The only time that didn't happen, I wonder if we took some different examples. If we took like a 4 and a 5 and a 10, if that wouldn't work either. That might be something for you to explore. All right, so here is the pattern. What are we noticing about the three side lengths? How are the sets of the three side lengths that did not form triangles different from the sets that did form the triangles? Okay, we'll get there in a second. So let's go ahead and read through these. I would like for you in your journal to write down the response here to this question here. Look at your data for the combinations that did not form triangles. How are the sets of these sides different from the sets that did form triangles? Go ahead and write down your response based on what we had just said here. It has to do with the fact that if the first two sides don't add up to at least this, it's got to be greater than that actually. The third side, then it's not going to form a triangle. And that ends part one. So I feel like you should make a statement. Under what conditions do you get a right triangle in the middle? Under what conditions do you get an acute triangle? And under what conditions do you get an obtuse triangle? To finish off this lesson, just go ahead and write down those observations. And then tomorrow we'll complete the lesson. We'll get into part two when we actually start creating a statement for those situations. But we'll stop today with this. Go ahead and get started on your homework, and hopefully you'll do fine with that. Tomorrow, first thing, we'll go over some of the problems in the homework, and then we'll continue with this lesson. All right, take care.
Hey, feeling good, like I should.